Okay, so for the hair gel lab, there's some preparation you're going to need to do the night before. And there is solution A and solution B. Solution A will be your acid, which has carbomer 940 mixed with water. Solution B will be triethanolamine, 28 milliliters with 40 milliliters of water. So you need both of those different ratios. This thing of water I got is very close to 3.91 liters. It is 3.78 liters, so this is what we are going to be using. So as you can see here, I have a scale and I made sure to tare it, or I set the weight to 0 with this cup on top of it. So that means any powder I add will be the weight. So I'm going to weigh out 28 grams of carbomer 940. And if you haven't noticed, I'm wearing gloves because we're dealing with acids and bases and this stuff is still concentrated. Also, I have very sensitive skin. If you have sensitive skin, I strongly recommend gloves. Okay, so this is 12. I'm going to need 8 more. And try tapping it so that it goes out of the cup. Okay, so I used a container without much extra space. You might need to use something to like plunge it through before you continue mixing. However, if you have some water measured out, it might be easier to add the powder first. Okay, so the reason you need to prepare this at least a day ahead of time is because this carbomer 940 is not going to want to dissolve. Also, make sure you label your solutions so you can tell them apart. So I labeled that one solution A, and this one will be labeled solution B. So for the other solution, solution B, you need to pour about 28 milliliters of triethanolamine. So that's pretty much just 30. So I have a graduated cylinder. And I'm going to fill that to, 28, 30 milliliters. Okay, so I have that. And then you need about 40 milliliters of water. So I have my water right here. So in total that's going to be about 70 milliliters. So now that there's about 30 in here, I'm going to fill this to about 70. Which means you'll have about 30 triethanolamine and about 40 water. And then I'm just going to find a container for this. And another tip, if you have a stir bar for solution A, it can make your life easier. A stir bar would just be a small little magnetic kind of pill-shaped item, and you would have a stir plate and there would be magnets that would allow that to spin. So if you do have access to that, that might help. Otherwise, I'm just going to occasionally mix this and try and let this dissolve overnight. So this is pretty much what I have. I need to put a label on this that says solution B, but what I was telling you was just the ratio, so you're probably going to want to make a lot more than that. So just remember, for about every 28, 30 milliliters of triethanolamine, you need about 40 milliliters of water. And this is a 500 milliliter container, so you might want to just make sure that this is around 500 total, but you know the ratios now. Okay, so right here I have the solutions. This is the solution A that we prepared earlier. If you don't have a stir bar, you might need to shake the container that you're making it in occasionally. But anyways, here's my finished solution A. It's kind of cloudy looking. So solution A is the carbomer 940 one. And you're going to need something to measure out some solution A to put into one of these little cups. So I have this right here. You might want to just do only a teaspoon, but it's up to you. Just be consistent with how much you put in each cup though. And now we're going to add some solution B that we prepared the other day. So what we're going to do is we're going to drop this in and we're going to mix it. And you're going to notice that it's starting to get more viscous, and viscous means that it's harder to mix, it's becoming a little bit more solid-like. So the more I'm mixing it and adding it, the more viscous it's becoming. So you can see that both of these two liquids are starting to become a little bit of a solid. This is actually in between a solid and a liquid. So it might be nice for the kids to count how many drops they had to add, and then they could also always keep adding and see what happens. And this is becoming noticeably more stiff and viscous and hard to mix with the more solution B I add. And then you might want to ask if the children participating would like to predict what would happen if you kept adding solution B. I'm not going to because I don't have that much. Or you could also ask them what would happen if you kept adding solution A. And as you can see, it's becoming a little bit less solid and it's going back to a liquid. So they might predict that as it becomes more concentrated on one of the other solutions, it will go back to a liquid. And then the children can observe that solution A and B combining in the right parts creates a product. So this is a great experiment for seeing how different ratios can combine. Oh look, it's becoming solid again. But anyways, you can just sort of play around with the different ratios of solution A and B and see how that changes the viscosity. And that's it.